In this video, we're going to take a look at the screens. And this will just be a general overview of the screens, just so that people are a little bit more comfortable with all the controls that are on them. I get a lot of comments about complexity of the screens, but they're really not overly complex, and they follow a general rule of, if you don't know what it is, don't click it, don't use it. Eventually you'll come to a eureka moment where you say, that's what that control is for. That's a natural progression in using any program, but especially so in Mach 3. So let's take a look at the screens. Pay attention when I use certain terminology. It saves a lot of support time. If you send me an email saying the number thingy on X isn't displaying properly, it's just going to cause an email to come back to you saying, do you mean the DRO? You'll see a lot of people on the group correcting people's terminology at times. They're not doing it to be mean. They're actually doing it because it's a lot easier to convey information between us all if we use a standardized terminology at least. That having been said, let's take a look at the screens. Here we are on the program run screen. There are 6 screens across the top. You can see we have program run, which is where we are. We have an MDI, or manual data input screen. We have a Toolpath screen, which is good for looking at whatever toolpath you have loaded and seeing what its program limits and so on are. We have an offset screen, which you can use to set your offset systems. Here you can see we can switch from G54 to G55 and G56. You'll notice that the buttons do nothing many times unless we're in a reset condition. When we're reset, suddenly things begin to work. The control internally does not like to do many things if it's not in a safe condition. Switching coordinate systems is one of them. We'll go into this later so that you understand what those all are. We have a settings screen, which is a bit messy and the last screen to be cleaned up. It has special items on it for specific types of uses. Tangential knife control. We have feed rate controls and CV controls for plasma tables. And various controls. Some of these will go away very shortly, and others will be just simply cleaned up. We have the Diagnostics Screen, which everyone is familiar with from the previous videos. This is probably the most important section up here that shows you the LEDs that you have, LEDs that represent the signals that you have connected to the system. You can see that they're all out on mine, and they should be. If I press a home switch, you'll see that the home switch light comes on, and if I release the home switch, it goes out. That's the normal operation of these LEDs. Typically, you'll have none of these on when the signals are not active and the program's in a normal runtime state. Normally, the only thing you'll see flashing around when you're not moving is this time in interrupt DRO, which shows the number of microseconds that the driver is currently spending on each iteration through its interrupt cycle. I don't expect many of you to understand what I just said. Just take it from me that this number should be flashing, and it's quite normal. It should be less than 15 on all systems, and you can see mine flashes between about 6 microseconds and 4 microseconds, depending on how much housekeeping needs to be done at that particular interrupt. So let's go back to our program run screen. This box here is the G-code display box. You can see that if we load a G-code file, I'm just going to go to the Mach 3 folder into my G-code. There's examples. There's the famous Roadrunner file that I always use as an example. And you can see the file is listed here in the G-code display window. By clicking into the window, we can scroll with our mouse wheel one line at a time through the program. And you'll see over here we have a white dot. That represents this single line of G-code. And as I scroll, you can see the white dot moving. Sometimes it'll disappear, and this usually is because it's too small to display on that particular line. But this is a handy feature for scrolling back through and finding a troublesome spot on your code. Clicking once again will take you out of focus for that window. The Toolpath window itself, double-clicking will reset it to a plane and reset it to a size. The red box going around our toolpath is simply the extrema of the file. These are the program is telling you this is the highest Y value you have, the lowest Y value, the minimum X, and the maximum X values. We can take a closer look at that toolpath by going to the Toolpath window. Now you can see, once I've clicked in the window, if I rotate my mouse, I'm zooming in with my mouse wheel and zooming out. Double-clicking resets us. You can see the dashed lines are rapid moves between cutting segments. The dark blue lines are actual G1 feed lines, and if there were light blue lines here, those would be G2 or G3 arcs. You can rotate it by clicking in it and rotating around. Again, if you get lost, double-click and you're back to normal. If you hold down the Shift key and move your mouse back and forth, you can slowly zoom in and out on the picture. And by clicking down your right mouse button and moving the mouse, you can pan it around. And those can be combined. We can zoom in and pan on the zoom. We also have a mode called Jog Follow, which resets the drawing so that you can jog it around and actually see where you're going from the jog. I'm going to switch us to a normal jog mode here. Now, whenever you zero DROs, these are the DROs, by the way, digital readouts, this yellow line, two yellow lines, shows the X and the Y axes intersecting. So at this moment, my tool is centered somewhere up around this Roadrunner's foot. If I jog my axis, you can see that the drawing moves to show where the tool is currently at when I'm in Jog Follow mode. If I turn off Jog Follow mode, the lines move to show you where you would be. Again, double-clicking will reset the system. If you zero DROs, you could just see that those lines moved to the 0 point or the origin point of this piece. It's important, though, whenever you zero DROs, that you do a regen of the toolpath so that the system recoordinates the toolpath display with actual coordinate positions. When you're running a file, here we have a cycle start button. When you're running a file, it will draw in green and show you as it cuts that particular path. Clicking once on the image at any time will clear away that green line so that you can see a little bit clearer in case it's obscuring your view. We have a feed hold button, which, as you can see, stopped the movement, showed us what the next line is, and from there we can hit cycle start and continue. Or once feed held, we could, for example, hit reverse, and the program begins to run backwards. Hitting feed hold will turn off the reverse mode. Hitting cycle start will go forward again. Reverse is handy for plasma people. It's not real handy for mill, although it is used by some. Stop, of course, stops the program. Stop will stop a program. Hitting the escape button will stop a program, and hitting reset will stop a program. We also have an Edit G-code button, which will bring up an editor so that we can edit and change anything in the code that we wish. Closing the editor will automatically reload the file and display any changes that you've made. We can close a G-code file with this button. We can load G-code files with this button, but we have a recent file button which will give us a list of the last 10 files that we've used. We have a rewind button which rewinds the G-code. Single block puts us into a mode where pushing cycle start will execute one line at a time. Turning off single block, we could then continue the cut from there. We'll hit stop and rewind. We have a set next line button. You'll notice if I scroll through this, it tells me which line I'm on. I could either say set next line, in which case the program counters have all been set to this line and pushing start will simply start moving from that point. That's not really a safe way to start a G-code file in the middle. The safest way to start a G-code file in the middle is to scroll your G-code down to the line that you wish to start from and clicking run from here. This will force the program to run the file internally to that line in order to set all previous states to the correct position. You'll see we get a message, press cycle start for preparation move. If we push cycle start, it will tell us where that line in the program is, and it knows we're not there. And it will then go to that position, and we're ready for a cycle start. We have a tool information line, which shows us what our current tool number is, diameter, length of the tool. This light change tool will be flashing when the system is telling us to change our tool, and we'll get a message down here asking us to press cycle start when we have changed our tool. We can turn jog on or off. This button probably doesn't belong in the tool information, but it was a nice spot to put it, and it was empty there anyway. We have an offline mode, which stops any output from going to our motors in case we want to run a simulation and we don't want our motors to move. We have a go to Z button, which means go to zeros. Pressing this button tells all our axes to go to the 0 point. We have a machine coordinates button, which when pressed will show us our machine coordinates of the current position versus our work coordinates. The next video will go into explaining the difference between the two. We have a soft limits button that we can turn on as long as our axis is currently within the width and height of the soft limits that we have set. Again, this will be the subject in the next video as well. Here we have scale values that we can scale an axis. If we were to, for example, type 0.5 in the X scale, we get a warning that the X is now scaled. Hitting Regen Toolpath, we can see that it's now scaled to 0.5 of what it was. Setting this back to 1 will turn off our scale warning, and regenning, we can see that we're now back to a full file. We have a feed rate selector. This is feed rate override. We have units per minute and units per rev that are real-time updates as you're moving. Here we have our spindle speed selection. We can turn a spindle on or off. We have spindle speed override, that we can override the spindle speed that was set in the G-code program and allow the spindle to speed up or slow down. Pressing reset will of course bring it back to 0. This section of the screen here is used for multipass. Again, you don't need to worry about it unless you know how to use it. Generally though, if you have a G-code file which is set to a particular depth, say it's set to cut to -10, you could hit multipass and tell that file to cut 5 times, dropping 2 each time until it hits 10. So it is literally a multipass selector, allowing you to cut a file in multiple passes. Here we have a wizards button, which allows us to select any of the wizards that are in the system. And we also have a last wizard button, and if you have selected a wizard in the past during that session, it will just bring it up quickly again for you. We have a conversational button, which will switch us to conversational screens. This will be the subject of a video of its own, but here we can select material and calculate what our feeds and speeds should be, and then we can select various automatic conversational systems to do jobs that we might not want to go to a CAM program for, or things which can be quickly done through a wizard. Pressing exit will take us back to our normal screens. You can see that the wizard I was in already started to post a program. We didn't select any real programs, so we don't get much code from it. Hitting our recent file list, we could select our Roadrunner again, and there's our famous Roadrunner. Here we'll display the file name that you currently have loaded, and here's a reference button to send all our homes to 0 to our home switch. If we press reference, you'll notice that the y-axis is now moving up, and now it hit its switch, and now the x-axis is moving to its switch, hits it, and then backs off the switch. These are simulated, and you'll see that the x-axis went forward to its switch, which it normally wouldn't do. I haven't set this system up for homing. We'll do that in the next video when we discuss work offsets and general coordinate systems themselves. If we take a look at the MDI screen, again we have our DROs repeated. It's handy to have DROs on most of the screens so you know exactly where your table is at. We have 0 buttons for zeroing the axes, and another reference button here, the scaling. Radius correction is used for 4-axis work, where you can tell the system the actual circumference size of the object, and it will correct the feed rate to create a toolpath that feeds at the correct rate on the circumference of a rotating object. Again, something that you can ignore unless you understand what they're for. We have dereference all axes, where we can tell the system that we're no longer homed. These LEDs turn green when we are homed. Offline again, machine coordinates. And we have a verify button. The verify button is used if you want to check to see if you've lost any steps in your running of various programs. It will send the axes back to your home switch and then bring them back to where you were when you pressed verify and report to you any lost steps. Scaling off button will turn off any scalings that are in effect. If we had a scale of 0.5 on our X and we wanted to get rid of it, we could just press off. We have a stop button. We have a start teach and a stop teach button. These are teach modes with MDI. You can actually write a program and type in the commands as you go. The teach will remember any commands which are typed here into the MDI and create a G-code program from what you've typed. We have a set variable position. If we go to a particular position, we can say set that as a variable position. And later on in our program, if we're somewhere else, we could say go to variable position and it will return there. Think of this as memory plus on a calculator and memory recall. We've duplicated the feed rate and spindle speed controls here, and the jog on and jog off controls for safety's sake, in case you want to make sure that you don't hit an arrow key and destroy your work while you're playing around. The input line here for MDI records your commands as you type them. If we do a G0, X0, Y0, for example, you can see my axes just moved to 0. And this little box here is a history box, which now displays that command. If we type G0, X10, the history box is just grown by 1. And by pressing the up or down arrows, we can scroll through those settings and recall them. Pressing enter takes any command, and pressing enter on a blank line will exit you from the MDI input. Also, pressing enter while you don't have the line selected will select the line and take it off. This is the Toolpath screen. Here we have DROs just to show you where you are. We have program limits that show you the range of the program. So your minimum X, which would be this point here, is 0. Your maximum X is 7.72, which would be this point here. We have a Regen Toolpath button, which regenerates the toolpath. These are buttons duplicated from the front page. You can rewind a file, single block it, reverse run it, stop it, or feed hold it. You can also estimate a program by hitting Simulate Program Run. No motor movement will occur, and you can see that the DROs are not moving, but the time is counting very quickly up to show you how long this job will take to cut at its current feed rate settings. It takes approximately a minute for every 10 minutes of program run simulation. So if you have a multi-hour job, this can take a little while to figure out exactly how long it's going to take, but it can be useful for calculating an estimate for a customer who wants to know how many hours of time it's going to take to simulate his or to cut his actual job. So this program will take 3 minutes and 56 seconds to cut at its current feed rate settings. We have a run from here button so that you can start the program from any point in it. We have an offsets page. This particular section here is used for setting a gauge block height. It means that you can put a block on top of your machine, jog down to it, and then set your Z coordinate to accuracy without the risk of the tip of your bit scratching your piece. And this is used by a lot of people as a safe way of setting their tool height. We have a current work offset, which shows us what the offset is in various modes, but primarily it shows what the current work offset is in the mode we have selected. Normally you will be set to G54 until you've gained a certain amount of expertise, and then you're free to select any of the other offset systems. There are in fact 255 of these systems, but we've given quick access to the first 6. Most people I don't think will ever need more than the first 6 that they have. Here we have an edge finder. selection. This can be used and is useful for finding the center of a circle or finding the edge of material. This is a duplication of the gauge block height with a few other help systems on it. These help menus will soon become active. We can turn on or off the tool offset as well, as long as we're not in Tool 0, which never has an offset in it. These buttons here will allow you to bring up a dialog to see what is stored in your work offset systems. Here you can see G54 through G59, and we also have G59 P7 through G59 P253. So there's a lot of offset systems that you can use. We also have a tool table, which will show us what is stored for each entry in the tool table. And again, we won't get into that until we've gone through showing you what exactly tool tables are and how to use them. The settings screen, which will change very shortly, is used for special jobs like turning on laser triggers to trigger measurement lasers across a grid of XY coordinates. We can set a rapid override, which slows down or speeds up our rapids. We can tell the system that when input number 4 is coming into the printer port to do a single step whenever it sees it toggle. Various settings, and you should need to use none of these as a beginning user. These were all fairly advanced settings and really aren't necessary for most people. The Diagnostics Screen has a couple things that are important. One is the pulse frequency. If your system is running properly, you should have a pulse frequency here. You can see that mine is deadlocked at 25,690. This should not vary much. It is a sign of a well-operating system that this number doesn't change and doesn't fly around. It won't affect you if it flies around a little bit, say 10 or so, but typically it should be fairly well locked. Most of the other settings on this screen are not very important to you at all, other than these LEDs. Then we have a tab screen, which is pulled out by pressing the tab key, and these are the jog selections in the system. I'm going to flick back to the program run screen so that we get a better view. You can see that the jog buttons will jog the axes with an on-screen jog. We have a slow jog rate, which we have set to 50% at the moment. Slow jog is what you get when you just simply press the arrow keys. If you look here, you can see my units per minute when I jog is currently 321 millimeters per minute. But if I press, that's a 50% rate. If I press the shift key, and when I press shift, you'll see this LED light up here on the panel. That's an indicator that you are now going to fast jog. So by pressing the shift key and pressing the X jog, you can see that we've now gone to 642 units per minute, double the speed that we were. This slow jog rate can be used to get very fine movement control from your arrow keys when you want to slow things down for very fine approaches. Pressing shift will take you to a high speed move so that you can move quickly away or to a piece. For jog modes, we can also switch to a step mode, which means that every press of the arrow key will move us this amount here, 0.01 millimeters. And you can see my x-axis as I press the key is now, each time I press it, moving 0.01. The cycle step can be cycled through. Now we've cycled it up to 0.1, and now each time I jog it will move 0.1. And you can set these cycle jog steps in the configure state menu. Here are the ones that we are cycling through when we press this cycle jog step button. You'll see an entry here, 999. 999 triggers the system to switch back to continuous jog. It's a way to get back to continuous jog just by cycling through. We have an Mpg mode, and in the Mpg mode, when you rotate your Mpg wheel, you will jog in one of 4 various types of jog. By selecting velocity, the faster you turn the jog wheel, the faster your axis will jog. By step velocity at the moment is the same as velocity only. It is a redundant mode and no longer required, but I'm going to leave it there for the moment. We'll fill it with a better mode soon. Single step mode will move you one single step whenever you rotate the wheel a small amount. You must stop between steps to get single step to work. Multi-step, you don't need to stop. You can calibrate your MPG wheel, rotate it 5 clicks, and the axis will move an appropriate amount for those 5 clicks of movement. This percentage reading here is not used at the moment. It is part of the old step velocity mode, which will again be replaced. There's a calibrating button here to calibrate your MPG, to tell the system how many encoder counts it will get per detent of the wheel and so on, and it'll calculate things out to make it work smoother for you. There's a shuttle mode which can be turned on. Shuttle mode runs a program by rotating the wheel. In shuttle mode, we could tell a program to start, and as you can see, it will not move, and it's waiting for us to rotate the wheel. If we were to then rotate the hand wheel, the program will then move slowly. As you can see, when I stop turning my MPG, the DROs stop moving. If I get rid of that, we can see the program is now moving. Now you notice it's cutting in the wrong place. That's because we did not regen the toolpath after all our playing here and zeroing. So it's important, I'm going to stop this again, regenerate the toolpath after you've been zeroing. I can now tell the program to start, and again it's not moving because I'm not rotating my MPG. As I rotate my MPG now, the program, as you can see, follows through and cuts only at the speed that I rotate my wheel at. This is a very handy mode for those who are nervous and want to run a program very slowly and a little bit at a time. And that's what shuttle mode does. Once I turn off shuttle mode, you can see the program begins to run automatically and will finish itself out unless I tell it to stop. That's about it for the buttons that are on the MPG and Jog tab. That's about it for all the buttons in the system, really, and all that you need to know to get started. In the next video, we're going to take a look at work offsets and offset systems to get you more used to that. And that's it for now.